For today's video, we will be talking about free radical hydrohalogenation of alkene. And so we will be talking about anti-Markovnikov in today's video. So if we have a structure that would look like this with a double bond, right, an alkene, and it was undergoing a reaction with HBr, right, HBr, and all over organic peroxide, right? So peroxide tells us this is a anti-Markovnikov problem. So meaning that Br would go on the carbon with the least amount of substituents, and so our product for this example would be like this, Br on this, and we would have a hydrogen on the carbon with the most amount of substituents, okay? And so this is our product for this problem. Let's do another set of problem. So for this, if we had the structure, and this is reacting with our HBr over organic peroxide. And so for this, we will redraw the structure. The double bond will go away, and the bromine will go on the carbon that has the least amount of substituents. And hydrogen will be on the carbon that has the most amount of substituents. And so this is our product for this. Let's do another example. If we have this structure, with the same reagents, with organic peroxide, the same thing goes here. Remove the double bond and add where the hydrogen would go here. Draw that. You don't have to draw the hydrogen, but always know that it's there. And the bromine would go on the other end with the carbon that has the least amount of substituents. So this is this carbon that is secondary, while this carbon is tertiary. So that is why it goes there. So this is our final product for this problem. So when discussing this reaction, we know that this is anti-Markovnikov. And so for this, when doing its mechanism, it is quite different from doing Markovnikov from this. So for this, they will have a three-step reaction. The first step is called initiation, right? So basically what this is that you would start with, let's say for example, you would start with two products like this, and it will form one radical plus another radical, right? So you would have two radicals on the product side. So two on the product side, two radicals on the product side. The propagation step is the next step. This is the second step. So the first step is initiation, the second step is propagation. In this step, you would actually start with, for example, one radical, and you would have it with something that is not with a radical. And so from this, you would actually end up having something going from this X not having a radical, finding the other compound element having a radical. So you go from one radical to one radical on the product side. So one on the left, on the reactant side, and one on the right. Then our final step, termination, is that we would have two radicals on the reactant side, okay, added with another reactant, and this would form into having zero radicals on the product side. So back to our original step, okay, we would have this. So we go from two on the reactant side, two radicals on the reactant, to zero on a product side, right? So initiation step is that we want to form radicals. Propagation is that we would switch around the radicals. And a termination is that we end the reaction. That is why we end having no radicals. Where initiation is that we would start with nothing and we would add radicals to start the reaction. So this reaction was a anti-Markovnikov reaction. And so for this, doing this mechanism, now we have a actually three steps in this place, right? So the first step is that we have initiation, right? Initiation. And in this step, all it means is formation of radical by breaking a bond. So for example, if I start with this, with a bond with another same thing, right? The bond will break having half arrows, okay? Because we're removing one electron. And so this will form a reaction having two of this having two radicals, right? So one radical plus another radical. So we have two radicals in the product side, on the right side. Our next step that we have here is called propagation, right? So propagation is that we would start with one radical on a compound and element, and we'll move it to the next having a radical. So for example, if I had this had a radical plus y, this will form a reaction having x not having the radical, but now y would have the radical. So we start with 1 x, x having the radical, just one electron, and then y would have the radical, and x would not. Now our last step for this mechanism is called termination. And on this step, all it does is that you bring the reaction to an end. So the reaction stops. So you can pick anything. In this case, I'll pick the easy one, simplicity. For this, we would have the two x's, and they will come to each other, forming a bond and having the reaction come close. So we start with two radicals in the reactant side, so on the left side. So as you can see, we ended with this, but we also started with this. So initiation and termination, you can say that they are opposites of each other. And that is the mechanism for this. So now let's start with a structure that would look like this, okay? An alkene, okay? And this is reacting with HBr over the organic peroxide, so ROOR. And so we were trying to find its product, okay? So we already know how the product would look like. The product would look like this, right? The Br would go on the carbon that has the least amount of substituent, while hydrogen go on the carbon that has the most amount of substituent. We know that, but now let's draw the mechanism of why this happens, okay? So we draw a line. Okay, so the first step, as we said, it was initiation, right? And on this step, we would actually start with peroxide, right? So we would have R, right, connected to an oxygen. This is also connected to another oxygen and connected to the R group, right? So from here, we have something called homolytic cleavage. Homolytic cleavage is that we will use one arrow, one arrows, to draw the electrons going. So something like this, and then something like this. So it's a half arrow. So this reaction will take place and will give us the R group, this oxygen, having two lone pairs, and then a radical, one electron. So it's an unpaired lone pair. Plus the other half, right? Two lone pairs, and then the radical. There. So now from here, we're going to start with this. And so from here, we would actually bring one of them down. We'll start with this actually. We're going to bring just one of them down, which will be this. With the radical, and then now this is reacting. This is adding with the HBr. This is from our problem. So from here, the radical, we will start actually with the double bond. And the double bond goes to form a bond with the compound, the RO compound. So use the half arrow over here, and then the other half arrow would come like this to form a double bond, to form a single bond. Now, we have to use the other arrow to give the radical to the bromine. Okay, so from here, we would have this. Oxygen does not have a radical no more, but it's connected to the hydrogen. And now also plus the bromine that has the radical. This is the initiation step. The next step we have is the propagation step. And in this step, we would actually start with the structure, like this. From here, we would actually bring in the bromine, right? The bromine. But this time, the bromine with the radical, so this. So it would come here, bromine with the radical. I'm going to put it right here. Okay? Remember, it has 3 lone pairs as well. So this bromine comes and joins on the structure. It joins onto the structure, so something like this. So a half of the double bond goes right here, with a half air, and the other half goes on the carbon that is attached to directly to it. Okay. Now this will form a formation of this. Right. Now the bromine is on the structure. Right. 3 lone pairs is on the structure. Now we also have that carbon has the radical now. Now take a look at this carbon. This carbon, it is tertiary, right? It's connected to 3 other carbons, and this is the most stable carbon. So this is the reason why this is anti-Markovnikov, is because the radical is on the carbon that has the most amount of substituents. Okay, and also this step right here is called addition to pi bond, right? So we broke the pi bond and added the Br radical to it. Addition to pi bond. This is the reaction to it. Now, our next step from this part over here is that we are actually bringing the HBr, okay, again, the HBr from our problem. And now from here, the radical comes and forms a bond with the hydrogen, right? Half arrow, and then it gives off the radical to Br, and so from here we get a final reaction of having the hydrogen connected to here, and the bromine is still on the carbon, plus also the other bromine that we have made the radical one, the 3 lone pairs. Okay, but this is our final answer. Okay, this is propagation step. We have one more step, termination step, right? Termination step, and this step is the easiest step of all. All we do is just look in our reaction and find 2 radicals. So in this case, for simplicity, we can bring on the 2 bromines, right? So this is the 1 bromine and the other bromine over here. So we can use that. The 2 that has radicals, right? Radicals. So they come in and form with each other like this to make a bond. Okay, that can be accepted as an answer. We can actually go more and do more reactions to this. So we can actually have our first one, right? So this is 1, and then our second answer, we can have this. This is from the initiation step over here. So they form a bond, and so we get peroxide, right? Peroxide. This is from this. We have made this. So the termination step, you can have as much as you want. There's a lot actually for this step. We have a lot of termination step, but writing 1 termination is enough for an answer. All it does is that you're bringing the reaction to an end. So that is actually, we can do 1 more. Peroxide with the bromine. All you need is just 2 radicals in the reactant side forming a bond with each other. So this would look like this. Br. Okay. And that is the answer. This is how you do the initiation, propagation, termination for the structure. Let's do another example where we have this structure, right? And this is reacting with HBr all over the organic peroxide. And so for this, we know how the product looks like. It will look like this, all right? Bromine on this, and then we have the hydrogen here. So we know how the product looks like. Now let's do the steps for it, the reaction. So the first step is also, again, is initiation. Initiation, right? So we're forming a radical. So we start with the organic peroxide. So we have this. another one, and connect to the R. So same thing comes in. We start with the bond, single bond. It goes makes a half arrow to the oxygen and makes the other half arrow to the other oxygen. Okay, so now we have this structure right here. Two lone pairs and plus the radical, one lone pair. One electron plus the other one. Okay, I think I should make it. Okay, add radical plus the other one, which has two lone pairs plus the other radical. Okay, now from this step, would you actually use this and bring it down? So the radical, and then from this step, we would actually bring in the HBr from our problem. So plus HBr. This has three lone pairs. Okay, now the bond goes and forms a bond with hydrogen. So like this, we have this, and then the electrons, one electron goes to the bromine to form a radical. Okay, so we have this step right here. Plus the radical that bromine has with the three lone pairs. Okay, we are done with initiation step for this problem. Now we go move on to the propagation step. Propagation step. So from here, we would actually use the structure. So let's use it. Right, we have this. Oops. Okay, has the double bond, the alkene. All right, now from here we have the radical Br. Right, it would come. Let's just put the radical right here. Okay, and now we have it forming one of the double bonds. Electron would go on to form a bond with bromine, right? And then it will go back on the carbon. So from here we would have this structure, bromine right here, and that carbon has the radical. The radical. Now from here we would have to react this with HBr. Okay, so we'll get rid of the radical. So we have HBr over here, and so from here we form it, making a bond with the radical, the hydrogen, and gives off the electron, one electron to form a radical with the bromine. So from here we would have this. Okay, the bromine right here, and then we have the hydrogen here, and our plus the radical that we have formed with the bromine. Okay, and our final step, is that it? Okay, well this is it for the propagation, and this is our answer that we have up here. That's it. Now termination would be the step to end the reaction. Okay, so we can pick anything. We just need two radicals. So in this case, for simplicity, we use the bromine, right? The bromine with the radical. They both have the radical, one radical. You bring it together to form a bond, one bond, single bond. So something like this. And giving an answer like this it'll be all right. Just give me one reaction.